Welcome to all of you. The topic for the presentation is 3D IC integration using blockchain. Myself, Dr. Adip Krishna, Associate Professor, Department of Physics, Mangalam College of Engineering. As you see, uh, the contents which I am presenting is the introduction, research aim and objective, literature survey, problem statement, the proposed work, results and discussion, conclusions and features. Now you know that 3D IC is going to be the new paradigm in the industry because till last 2 decades we have the 3D 2D ICs flourishing everywhere. Now we are moving towards the 3D IC where actually we will be having the multiple layers which is having heterogeneous structures connected between DSPs between itself. So 3D IC is going to have like a flat like structure. So we will be having more IC, more layers placed one over the other. So that will become reducing this total size, shape, everything. So 3D IC is having a wider applications in IoT because IoT is the future. A lot of applications are coming up. So 3D IC is going to be used in IoT. So just like a 2D IC, 3D IC's flow design flow is having steps, which is having 4 important aspects for an integration. That is like a partitioning, placement, routing, and TSV fault detection. But there is some kind of lack of security aspect is there when we go for this integration, which is a major challenging issue, and we will ultimately call it a security threat. But you see where the places where the security threats exist is that there are many stages are there in the design, and these stages which is includes in this design are like synthesis, placement, routing, and fabrication. So these attackers will be involvement can be encountered at any stage. uh, you see mostly when we work on, especially with respect to netlist, is one probable area where this can be happening. So we'll be expecting something like hardware trojans, malicious chip insertions, gate level attacks, power level analysis attacks. So many places we can expect it. So even though these are the things, the possible outcome because of this attack is that the performance of the chip can be degraded because increasing the thermal heat of the chip or to the inject the malfunction of the ICs is becoming a problem. So the necessity is that we need to overcome the attack and vulnerability so that we can improve the performance of the chip. And you see the necessity is that the security, you must be having some security provisioning, and we must have something like attack detection. See, there is a concept is there already, which is like a pre-silicon and post-silicon. In pre-silicon, basically very well useful for the with respect to the netlist analysis, and in post-silicon, it is like we call it as a golden model. Mostly in pre-silicon, some statistical methods are used to detect the threats, even though if it is not sure whether it is that much efficient. But there are certain cases where we have a detection of projects. For that purpose, machine learning, deep learning, etc., can be utilized. So the signals in the circuit, in the actual perspective, we can say that the signals in the circuit were guarded. So you can understand that if there is any changes happening, or if there is any abnormal events are happening, then that can be monitored. So these are some of the necessity part. Now, when you come to the aim of this particular research or work or objective, what we're looking at, the main challenge is that the poor accuracy in Trojan detection is due to the lack of important features. So there is something called high detection time, which is basically due to the ineffectual algorithms. And there is something like insecure netlist distribution, which can be founded over boundaries. And there is something like improper integrity management also. So these are some of the main challenges which we normally we face it. And if you look at the objective part, we can say that detect trojans accurately through deep analysis is one of the biggest objective. And the subject objectives are that you have to provide an end-to-end security for 3D IC design. You have to protect the netlist through optimal key distributions. You have to perform the optimal placement and routing in 3D ICs, and then we have to validate the ICs by learning unique features. So what's most planned here is that we will do something like integrity of this netlist, which we need to protect it, which you have to protect it by something like implementing a 4Q curve algorithm, which is actually based on digital signatures and storing of the data. So there's such tree hashing algorithm will be utilized for this purpose. And the hardware detection, that is especially the Trojan detection, we need to do that to perform so that too we can overcome that vulnerability, whatever that can be found in the circuit. For that, we will perform the specialized algorithm, which will be taken up at the gate level and chip level. And if you look at the placement of the IC block, we can do that optimally by using some improved algorithms for performance. So JSA is one such algorithm which can be implemented for this purpose. The route selection of signals we can perform by implementing the MWSM algorithm, which can be considered both this distance and thermal factor of the circuit will be taken into consideration. And at the end, we can do the dynamic validation of the IC with verification of signature performance. We can do that. So these are some of the things which we can plan. So now, if you look at the literature surveys, which is done in this such area, what we can understand that the paper title like automatic defective pin detection for recycled microelectronics identification, which came in Hardware and Security Systems Journal. Basically, they focused on CNN, which will improve their attack detection of accuracy. However, the work seems to be increasing the cost and only identifies defected pins which are ineffectual. And so there is another paper which was talking about robust design for security architecture for enabling trust in IC manufacturing and test, which came in the IEEE transactions. See, it actually improves the security, but still it requires additional pin to assure the features which is inefficient. And there is a paper which will talk about the multi-layer hardware Trojan protection framework for IoT chips. It actually came in IEEE access. And the research gap is that Trojan detection accuracy is low since several important features are not extracted by light chip, and therefore it should have high time and computational complexity. And the paper titled The Identification of Random and Clustered TSP Defects in 3D ICs During the Pre-Bonding Testing, which came in the Journal of Electronic Testing. And here the heuristic approaches are unable to provide optimum results which degrade the detection. And the paper titled Real-Time Detection of Power Analysis Attacks by Machine Learning of Power Supply Variations. So it came in transactions. Here again, prediction error is the most important thing without increasing it. And statistical method seems to be not useful for that. And the paper titled IP protection through gate level netlist security enhancement, which came in integration, which actually the problem is the complexity is very huge, time is consuming, and we are very difficult to reverse engineering it. And also the XOR based key generation is very much seems to be insecure. The paper title Spear and Shield Evaluation of Integrated Circuit Camouflaging, which came in Journal of Computer Science and Technology. Here actually the countermeasures are also introduced, named as click-based camouflaging. The paper titled Hardware Efficient Logging Camouflaging for Monolithic 3D ICs, which came in transactions. Again, the power reduction and security is achieved in the cost, where again the consumption seems to be ineffectual. And the paper titled Guided GA-based multi-objective optimization of placements and assignments of TSVs in 3D ICs, which again came in transaction. The time complexity of the proposed optimization algorithm was huge, which affected the placement process. A low latency, energy efficient BFP-based 3D NOC design with a zone-based routing strategy is there, which was proposed in Journal of System Architecture. The scalability seems to be improved by use of bridge routers. Then the power performance, paper title, the power performance and cost comparisons of monolithic 3D ICs and TSV based 3D IC. Actually, it came in IEEE SOI conference, but here what the gap is that the security of the 3D IC was not considered, which will also affect the performance. And the paper title, Dynamic Game for Security Selection in Hardware Trojan Attack and Defense, IEEE access, it seems to be there is a lacking in that. So that all these part will be considered together. What we can understand that there is something big need to be done. So there is a lot of research gaps are there. So although there is something like split manufacturing is existing, there are so many challenges like split dies are manufactured from different foundries. It always becoming very risky. Signal integration performance of the IC is becoming very poor. Then placements and routing is performed in a random manner, which is very ineffectual. And the split manufacturing only ensures that a foundry can be trusted and cannot have an overall knowledge of the netlist. The Trojan can be injected or inserted any part of any partition of the netlist. Such Trojans are not detected and mitigated in this work. So there is a possibility there. So generally what we have, the uniqueness we have, that the uniqueness of the gates in an IC varies whenever the thermal temperature increases, noise imputation can happen and other factors. And it is not possible to accurately identify the authenticity of an integrated circuit. So lack of deep analysis of IC data increases vulnerability and affects the authenticity accuracy of the work. So the work tends to identify the threats injected in the fabrication level through identification of location of the logic gates. However, the placement and routing depends upon the fabrication procedure can be easily modified. Here, the validation is performed only after chip verification. If chip is not authenticated, the IC is not taken further for the process. It seems to be very ineffectual. So what we can say that this boost algorithm, which is already predicted, will having it, which will extract only 56 patches. So it is again having a lot of lack of accuracy is there, and some trusted fabrication process problem is also. So the basic solution is we have to so you have to use some jellyfish search optimization algorithm, and we have to incorporate by blockchain into this, and supported by the Trojan-free netlist generation by the VFGRE algorithm. Then after that, we have to do the validation, which is done with an HMM-based signature generation. So the proposed work looks like this. So you have a design, you have a synthesis, placement and routing and fabrication. So you can see that the blockchain is introduced at the design level and to up to the fabrication level. And the netlist HSA protection is being provided. In all the cases in synthesis, you have the netlist encryption. In placement and routing, you have the Trojan detection. In fabrication process, we will be performing the special IIC validation. And in especially with respect to the Trojan detection, BFGRE algorithm is used, which is an optimal placement and routing will be done, where we will take care of jellyfish algorithm and the MWSWM based routing algorithm is being utilized. So this is the flow chart. Actually, we have started with netlist, extracting the gate and chip level features, selecting the important features from the extract features, train with GRE, calculating the update the GS timestamp. So timestamp is calculating the reset gate, which is using the past information. Then start the reset gate, and then is stored in relevant information from the past. Collected features are updated and holds current, which will take care. And further features will be looking at the netlist as well as the project effect. So in the performance, we will look the system which we used is this one. A system with a 8 GB capacity, hard disk here 60 GB, MATLAB. We have used 2020A. So we have used the input file as ISPD06 benchmark. And the output we got is we compared it with number of iterations in attack detection rate. Again, our algorithm is giving you the less attack. So it is giving a better performance. So in a number of iterations with netlist changing rate, again it is giving a better performance. Similarly, in power consumption, you can see power consumption is reduced, and in the case of the time consumption, again it is reduced in detecting. And for the area number of cells, again it is reduced, and for wire length is again reduced. So you can see then overall the performance like attack detection rate, netlist change rate, power consumption, time consumption, area and wire length, the algorithm which we propose giving you the least value, and it is giving very efficient result. So based on this, we can say that whatever the algorithm which we proposed, it will provide you enhanced security, and it will by deploying the SHA-3 hashing algorithm, the security can be improved and mitigating the Trojan attacks in 3D IC. So all transactions stored in blockchain so encryption can be properly enhanced. And at the same time, optimal placement we can ensure with the jellyfish search algorithm, as well as the multi-weighted sum model, which will be used for optimal routing. And finally, the trustworthiness of the IC is validated through signature using hidden Markov model, which will be done. We call it HM algorithm.